All right, so here's the quiz key part 2. So we're solving number 7 using a matrix equation and a calculator. Make sure you show the matrix equation. So the matrix equation that we're showing here, remember it goes the coefficient matrix times your variable matrix equals the constant matrix. So the coefficient matrix here consists of just the coefficients of these variables. So it's a 3 by 3. We've got 3, 2, negative 1, 1, negative 1, 2. Notice how these are coming from the coefficients of each one of these equations. Then 5, 1, 1. That's our coefficient matrix. Multiplied by our variable matrix. That's the x, y, z. X, y, z. Remember, it's whatever variables in each column. So column 1 is x, column 2 is y, column 3 is z. So we go x, y, z, just like that. And then this is equal to the matrix 6, negative 1, 7. Okay, that's supposed to be a matrix. Forgive the lagginess. All right, so to solve this on our calculator, okay, to solve this on our calculator, what we have to do is we have to isolate matrix x, y, z. So remember, if this were called matrix A, and this were called matrix C, and this were called matrix X, essentially you have A times X equals C. And the way we cancel out matrix A is by multiplying by the inverse of A on each side. So we multiply by A inverse on each side of the equation. That turns this into an identity matrix, which essentially cancels it out. So we end up with X matrix, and this is matrix X, the variable matrix, equals the inverse of A times C. So we enter this as A, we enter this as C, and then enter into our calculator A inverse C. All right, so here we go. It is calculator time. So we got to enter matrix A, which is 3, 2, negative 1, 1, negative 1, 2. So we go to second matrix, edit our matrix A. So it was 3, 2, negative 1. Forgot what the rest of it was. 1, negative 1, 2, 5, 1, 1. 1, negative 1, 2, 5, 1, 1. 1, negative 1, 2, 5, 1, 1. All right, so that's our matrix A. So now we go to matrix C, and C is already a 3 by 1, so we want to edit matrix C, and we want to change it into what it's supposed to be, and it's supposed to be 6, negative 1, 7. So we go 6, negative 1, 7. So 6, negative 1, 7. All right, and now we simply do, remember we're doing this operation, A inverse times C. So we're doing the inverse of A, so second matrix, we want A inverse times, second matrix again, C. And that right there, 2, negative 1, 2, is the solution, is our variable matrix, the solution to it. So we go, so matrix X, our X, Y, Z here, is 2, negative 1, 2. I think that was it, right? 2, negative 1, negative 2. Excuse me. 2, negative 1, negative 2. So that means X equals 2, X equals 2, Y equals negative 1, and Z equals negative 2. And you could write it like this, or you could express it as an ordered pair, 2, comma, negative 1, comma, negative 2, like that. Either one of those is a correct representation of the answer. All right, finally, we have number 8. Solve the following matrix equations using Cramer's rule. Okay, so Cramer's rule is it's a way we can solve matrix equations that still involves setting up a matrix equation, but then it doesn't involve using inverses. It only involves using determinants of matrices. All right, so here's what we do. First, we set up our matrix equation. So similar to how we did in the last problem. So here we need a 2 by 2. Whoops. 2 by 2. So we've got 1, 4, 5, 3. That's our coefficient matrix. And then if we were to continue this, we'd have x and y equals -2, 7. So that's our matrix equation setup. All right, let's name this matrix A right here. So this is matrix A. And what this involves is it involves essentially creating new matrices. We'll call them AX and AY that we create by substituting in this constant matrix or this constant column in for each row. So if we want to solve for x, we're going to substitute this -2, 7 in for the x column. Notice I call it the x column because it came from the x coefficients. So matrix AX is, so the 1 gets replaced by -2 and the 5 gets replaced by 7. So it's -2, 7 instead of the 1 and 5. And the 4 and 3 stay unchanged because we didn't replace the y's. This is the AX columns, we're replacing the x. All right, so AY, we do the same thing, but instead of replacing the x column, we replace the y column. So I'll change colors just to make it simpler. So -2 and 7 is going to go in for the 4 and the 3. So the second column is going to be -2 and 7. And the first column is still going to be what it was before, which was 1 and 5. So 1 and 5. So unchanged. All right. So to find what x and y are equal to, it's this formula that we need to follow. So x is going to be equal to the determinant of the AX matrix over the determinant of the original A matrix, which is our coefficient matrix. Y is going to equal, same pattern, the determinant of the AY matrix over the determinant of the original coefficient matrix. So this is using Cramer's rule. So we need the determinant of each one of these to be able to do this. Okay? And remember, AX came from replacing the x column with our constants. So that's how we created AX. And AY is the same thing. We replaced our y column with the constants. All right, so we need the determinant of AX, A, and AY. So let's just set those up. So the determinant of A, we multiply 1 and 3, and we subtract the product of 5 and 4. So we do 1 times 3 minus 5 times 4, which is 3 minus 20, so -17. So the determinant of A is -17. So that's going to be -17 in both of these equations. All right, and then for AX, we need the determinant of AX. So determinant of AX is going to equal -2 times 3 minus 7 times 4. So I've got -6 minus 28, which is -34. And look at that, -34 over -17 is 2, so x equals 2. And then to find this, we find the determinant of AY, which is 1 times 7. Again, remember, diagonal minus the other product of the diagonal minus 5 times -2. That is 7 plus 10, which is 17. So AY is 17. We got 17 over -17, which is -1. So X equals 2 and Y equals -1, which you could also express as 2 comma -1. Either one of those representations is just fine. That concludes the video key of the 757A quiz.